All right, in this video, we're going to talk about two ways that we can represent atoms. We have talked about the different models that were presented throughout history, and today we're going to concentrate on one of those models and then another way to represent atoms. So that model is the Bohr model, like this, and then the second way to represent it is through the Lewis dot electron dot diagrams. So let's take a look at the Bohr model of the atom. So if you could please take out your atomic theory concept map that looks like this, we're going to fill out a couple of the blanks. So to read these concept maps, what you do is you start in a box, so say the elements, and then move on to the next box. So here's what you would write for this. You would say elements are the most fundamental of the substances, of which there are approximately 100. I know on the periodic table it shows up to 118, but about 100 are the number that are useful for humans in pretty much everyday life. Okay, now elements are composed of what type of unit? They're composed of one type of unit called atoms. All right, and we already knew this. Okay, but what are atoms composed of? So atoms are composed of three subatomic particles. One is the electrons, which we talked about yesterday when we were talking about J.J. Thomson and the experiment that he did with cathode ray tubes. And the second particle, which is in the middle, are protons. And we haven't specifically talked about protons, but now we are. Now, protons are a very important particle in an atom. And I would say they're the most important because they give the atom its characteristic. So let's take a look at a vocab definition. The vocab definition is the atomic number. And the number of protons in the nucleus of an atom is the atomic number. All atoms of the same type have the same number of protons, without exception, all the time. Okay, so if we look at box number 3, we see atoms of the same element have the same, and then 6 atomic number. And we can extend this from 6 to 5. We see atomic number is the number of protons. Okay, so those are things that you need to memorize, and this concept map helps us to see how they're all linked together. You can see on the periodic table of the elements that the atomic number is listed as the bold number in each box of the periodic table. You should take your periodic table out and take a look at that and see that you have the atomic number for each of them. And for example, if we have chlorine, chlorine has 17 protons because its atomic number is 17. So make sure in your head you know that the atomic number is the number of protons. Not only is it the number of protons, but in a neutral atom, the number of particles are equal. We're going to see that in a second. Sorry, I'm jumping ahead of myself. So electrons, as we know, have a charge that is negative because of J.J. Thomson's experiment. The beam was attracted to the positive plate. You can go look at that diagram again in assignment number 1 if you need to. And we know protons have an electric charge that is positive. Now, in an atom, we know that they are neutral. If you go up to the top to number 3 and go over to 9, we know atoms have an electric charge that is neutral or 0. That means that the number of electrons, which are negative, must equal the number of protons, which are positive, in an atom because atoms are neutral. That just makes sense that they would be that way. And now let's take a look at this, and we're going to take a look at something called, first of all, let's look at the number of protons in carbon. We know that there's 6 protons because the atomic number is 6, but we also can look at the numbers right below it, the electron configuration. And if we add those two numbers together, we see that we get 6. Those numbers are telling us how many electrons are in an atom as well. And you might think that's redundant information, but the electron configuration tells us some more information. So if we look at the definition of electron configuration, it says that it's the arrangement of electrons in an atom in its ground state into various orbitals around the nuclei of the atom. Now, orbitals or energy levels is fine. So let's take a look at what this means. So if we look at hydrogen, hydrogen has one proton because its atomic number is 1. It also has an electron configuration of 1, and this is how we would draw a Bohr model of the atom of hydrogen. For helium, it's very similar. It's got 2 protons, and it's got 2 electrons. The protons go in the middle, and the electrons go in the outside. Lithium is a little different, so it's got 2. You can see the 2 that are going around it, but we're going to add a second ring for this third electron. Looks like this. Now, if we look back at hydrogen and helium, you can see that they are in the first row, and lithium starts the second row. And you can notice that if we looked at these, you've got lithium has 2 energy levels, and the other ones had only 1 energy level. So each row on the periodic table begins a new ring around the nucleus or the center of the atom. Right? If we look at beryllium, we can see that we've got 2 and then 2. And beryllium is right next to lithium. If we go all the way to the end, to neon, what's that going to look like? Neon is going to have 2 and then 8. And now that second electron shell has been filled, and we've got to go to the third level. Now here's an example from the fourth level. If we have chromium, you can see that it's going to have 4 rings. 2 in the first ring, 8 in the second, 13 in the third, and 4 in the fourth. So now you should practice questions number 4 through 5 on assignment number 4. All right. Also, you should answer questions 1 through 3, and you could have been doing that throughout this assignment. So here's the answer to 4 and 4. If we look at this, we've got 12 protons in the center, 2 electrons in the first energy level, 8 in the second, and 2 in the third. Here's our answers for number 5. So if we draw the Bohr model with 3 energy levels and 4 electrons in the outermost ring, we're going to see that it looks like this. So we have 3 electrons. We look at the outermost ring to see where there's 4 in there, and that's what silicon would have. If we draw the Bohr model with a total number of 19 electrons, that means that it must have 19 protons as well. And so we would draw it in like this, and we know that this is potassium. All right, so drawing Lewis electron dot diagrams. This is an electron dot diagram of neon, but we're going to go and look at some other ones first. So let's take a look. So the vocabulary definition of a valence electron. A valence electron is an electron that's in the highest occupied energy level. So that's the outermost ring, or the last number in electron configuration. So how many valence electrons does a carbon atom have? If we look at the electron configuration, we can see that there's the Bohr model, and these in the outermost ring are the valence electrons. So it has 4. You can go ahead and practice on number 7. Try to find out how many valence electrons that these have. And here are the answers. So we can just look at the outermost number. It has 6, 1, and 8. Okay, so Lewis dot diagram. This is a diagram that depicts the valence electrons only as dots around the atomic symbol that represent the nucleus and the non-valence electrons. All right, so we know those are there, but we're not going to use a description of, or we're not going to draw them out. We're just going to use the symbol. So for example, lithium. Lithium has one valence electron, and so we draw the symbol, and then we draw one dot that represents that valence electron, but we're going to make sure that it is on at least one of these sides. Those sides are, those lines are not part of the electron dot diagram. They're just there to keep us organized when we draw dot diagrams for ones with more than one electron. So that's what it would look like right there. Very simple. How about for carbon? Carbon has 4 valence electrons, and we're going to, again, think about the sides as having lines, and we're going to draw one dot on each of those lines like this, and then get rid of them, and it would look like this. So you don't have to draw those lines. That's just there in your imagination. Think of those lines because you want to draw these as if there were lines there, especially when we have more than 4, which we're going to do right now. So for oxygen, then we write the symbol. We look at how many valence electrons it has. We draw in our mind. We think about where those lines are. You don't have to actually draw them. And let's do the first 4. And then we're going to pair the last 2 with the one on the top and the one on the right. And that's the electron dot diagram for oxygen. We can't have those dots just randomly around oxygen. Those 6 have to be placed as if there were lines on each side of that symbol. So for neon has 8 valence electrons. We're going to actually put the dots on every single line, and of course 8 would fill up the entire area around neon. Okay, so notice how they're paired nicely on each side. That's how you need to draw your electron dot diagrams. So let's practice doing potassium, sulfur, and aluminum. That would be question number 9 on your practice assignment number 4. Pause this video while you try that, and then here are the answers. So, of course, potassium would just be with 1, sulfur would have 6, and aluminum would have 3. And that's how you represent atoms with a Bohr model and with a electron dot diagram.